So today I am going to start with the linear interpolation, then I will switch over from linear interpolation to the polynomial interpolation, and under this polynomial interpolation I will talk to you Lagrange's interpolation, right? So Lagrange's interpolation is in your course, but linear interpolation is not in your course, right? So first of all, to introduce this interpolation, I will start with the linear interpolation, right? So what is linear interpolation? It is the simplest form of interpolation. This linear interpolation is the simplest form of interpolation. And what do we do? That means we will choose two data points and find the line. That means these two data points are approximated by a line, right? And then we will find out any point in between those two data points, right? So let us choose or let us draw a diagram. Suppose मेरे पास एक x-axis है and then it is y-axis, and this y is nothing but is equal to f of x. So in general, when we do certain experiment, data is not linear. Data is non-linear. So in general, the trend of data may be like this. Actual data will be like this. And out of this data points, let me choose 2 points. Because when we do some experiment, I can choose out of those experiment. Means a certain data point, say one point is this, another is this, and another is this. But I am interested to find out its value somewhere here in between these two data points, let us say. And there is also another data point like this. So let us choose any two data points. So say this point is, one point is this one which I am choosing, and another point is this which I am choosing. And what I will do in linear interpolation, I will join these two. Means I will connect these with the help of a line, right? So if I want to find out the value in between these two data points, then that is approximated by, and say I am interested to find out is any point in between here, right? So that means what I will do, I will fit a line over this, and then using that I can obtain this point, and this is very close to this point, but there is little bit error in it, right? So this is a way that how we can find out certain value in between two given points. When 2 points are given to you, then how to decide that point. This is a way to look at that, right? So let us draw perpendicular from here to here, and these are the two given data points, and this is some unknown point where I am interested to find out the value. And if I join these, then they can be joined like this, and then like this. So let me call this as P1 point, and let me call this as P2 point, and say it is Q point, it is R point, and say it is the P point at which I am interested to find out the value. So I have given 2 points, means 2 data points we are given to you. What is that? Corresponding to P1, I have given x1 and f of x1, and another point which is x2 and f of x2, and there is another point which I have taken, that is x and f of x. It is some unknown value. Means corresponding to the x, I am interested to find out f of x, which is unknown to me. So there are different methods to determine it. So first method, whether I will talk about P1 P line or I will talk about P1 P2 line, both are same. That means both have same slope. Means slope of what? Slope of P1 P2 must be equal to slope of line P1P. Slope of line P1P, both are having the same slope. What is slope? Change in y upon change in x. Slope is nothing but change in the value of y upon change in value of x. So for P1 P2, the change in y will be what? This is the change in y which I am considering, and change in x, this is the change in x which I am considering. And what is this? This change is x2 minus x1, and this change is what? fx2 minus f of x1. Is it visible to you? Okay. So it is f of x2 minus f of x1. That means what I can do, using this idea, I can write down f of x2 minus f of x1 over x2 minus x1 is equal to, what is it? F of, and what is here? It is f of x minus f of x1, and here it is x minus x1. This is the change in x. So I can write down it as what? It is equal to f of x minus f of x1 divided by x minus x1. So now I can find out the value of x from here. I can find out the value of f of x. Now my objective is to find out the value of f of x, and let us see how this can be evaluated using this equation. So bringing this towards that side, so it is x minus x1 f of x2 minus f of x1 over x2 minus x1 is equal to f of x minus f of x1. Bringing this towards that side, so f of x can be written as f of x1, right? F of x1 plus x minus x1 f of x2 minus f of x1 divided by x2 minus x1. So this is the formula for the linear interpolation. This is the formula for linear interpolation, right? So it is f of x is equal to f of x1 plus x minus x1 f of x2 minus f of x1 whole upon x2 minus x1, right? So this is the formula for the linear interpolation. Formula for linear interpolation, right? Now let us understand this linear interpolation with the help of some example. So let us take an example. Example is that you are given the value of x and f of x is nothing but root of x. It was given to you, and for 1 its value will be 1, and when x is 2 then it is 1.4142, then for 3 it is 1.7321, and for 4 it is 2, and for 5 it is 2.2361. That's what we are getting. So say this is the set of data points we are having. Let us assume that, or it may be any experimental data if you will have it, right? So that means And what is our objective? We are interested to find out 2.5 under the root. So for the given data points, where it is lying between 2 and 3. It is lying between 2 and 3. So that means x1 is given to you 2 and x2 is given to you 3, and corresponding to it, f of x1 is what? F of x1 is, what is f of x1? It is 1.4142 and f of x2 is 1.7321, and we are interested to find out corresponding to 2 that what is the value of f of x, because it is x. This is our objective. Now what I will do, I will apply the formula. What is the formula? Formula is for the linear interpolation that f of x is equal to f of x1 x minus x1 plus f of x2 minus f of x1 divided by x2 minus x1. So let us put their values. So if I put their values, what I am getting, f of x1 is what? 1.4142 plus what is x? I am interested to find out f of 2.5. So it is 2.5 minus 2.0, and what is f of x2? 1.7321, 1.4142 divided by what? Divided by 3.0 minus 2.0. And when I do little calculation, I will get that 1.5732 will be the answer. Right? And what is actual answer? Actual answer is 1.5811. So it is little bit far away from me. But let us do one more thing. This is sufficient, means this question is done. What if I will take a different set of points, means if I will take 1.2 and another 0.4 and ignore 3, then what will happen to the result? Let us see. So if I take x1 is equal to 2 and x2 is equal to 4, then what will happen? F of x1 is 1.4142 and f of x2 is equal to 2, and if I put their values here, then f of 2.5 will be what? Now points has been changed, means the size of the interval has been increased. Earlier it is difference is 1, now the difference is 2. And if I take a large difference, large interval, then how it will affect our result? That's what I want to see here. So what is it? It is 1.4142 plus 2.5 minus 2, and here it is 2 minus 1.4142 divided by 4.0 minus 2.0. If I put these values, then what was the answer? Answer is 1.5607. Means what will happen when interval increases, then this value is more far from this and this value is more closer to this value. So that means when interval increases, error will be more. Error will be more. So what does it mean? This means that when smaller the interval, between the interpolating data points, the better will be the approximation. And even error is again more, little bit more. What is the reason behind that? That why this error is so large in comparison to this? Because when we do experiment, need not necessarily that data is always linear. Means experiment or the relation between the set of data points is always linear. It is most of the times it is non-linear. So non-linear nature of data or the experiment, but what we are doing, we are trying to estimating the data points with the help of a linear interpolation. So that means can we switch over from linear interpolation to polynomial interpolation or non-linear interpolation? This is the main disadvantage of this linear interpolation. Let us try to understand it with the help of the example. Say this is the data points we are having, right? These are the data points, and let me try to plot these data points. Say it is 1, it is 2, it is 3, it is 4, and it is 5. These are the data points, and corresponding to 1 it is 1. Say it is 1, 2, and it is 4. This is 1, this is 2, this is 3. So 1 will be lying somewhere here, and 1.414 is where? 1.414 is lying somewhere here. It is somewhere here. 1.414 is lying somewhere here, and 1.73 is where? 1.73 will be here, roughly, and 2 will be lying somewhere here. 2 will be here, and 2.23 is, it is lying somewhere here. So that means the data points is like this, it's like this, it varies like this, but 2.5 is lying somewhere here. So it is like this plot is like this, but when I will join these points, then they are joined like this. So this is the error, because the given data points are varying non-linearly, but approximation which I am using, that is a linear approximation, and when I am using a linear approximation, that means error will be more. So that means this can be improved by polynomial interpolation. So now I will talk about the polynomial interpolation and how that can be done. That's what I will talk to you, right? So first of all, let me talk about a polynomial, that what is a polynomial and how it can be represented. So let me talk about polynomial interpolation. So let us understand that how a polynomial can be represented. Simplest way to write down a polynomial is that a0 px is equal to a0 a1x a2x square plus and so on an x raised to power n. And once we know this a0, a1, a2 and so on, that means once this polynomial is known, and to determine that polynomial, what should I know? I must know that what are the values of a0, a1 and a2 and so on. Once these values are known, that means we can estimate the polynomial. Then there is another way to represent a polynomial, that is a shifted power. If power is shifted, then shifted power way is what? it is a naught plus a1 x minus c. C is any point, constant value is c, right? Means this is shifted. So plus a2 x minus c square and so on, a n x minus c raised to power n. This is another way to look at it, right? And this is also generalized. Shifted power form can also be generalized. So there is another way to write down a polynomial. It is generalized shifted power form, and this is known as Newton's form. And how that can be represented? It is Px is equal to a naught a1 x minus c1 plus a2 x minus c1 x minus c2 and so on, sorry, not so on, but plus a3 x minus c1 x minus c2 x minus c3 and so on, an x minus c1 x minus c2 and x minus cn. This is another way to, all are representing the polynomial, right? Then, but this method is not so good. But if I want to incorporate every data point, and to incorporate every data point, there is a different way to represent a polynomial, that is to incorporate, or to another way to incorporate or to represent a polynomial is to incorporate every data points, or every means data points given in the experiment. So what is that? Say Px is equal to a naught. When I am talking about a naught, then it is x minus x1, x minus x2 and so on, x minus xn, right? Means I am not considering x naught here. Data points क्या है मेरे पास? x naught, x1, x2, x3 and so on, xn. These are the data points. I am happy. So that means when I am taking a naught, I am not incorporating here x naught, and these are n linear factors. When n linear factors are multiplied with each other, we are getting x raised to power n like term, right? Plus a1. When I am taking another coefficient a1, then I will start with the x minus x naught, x minus x2. I am not considering now x minus x1, x minus xn, plus a2 x minus x naught, x minus x1, then after that x minus x3. I will not considering x minus x2 and so into x minus xn, plus and so on. It is an, it is x minus x naught, x minus x1, x minus x2 and so on, x minus xn minus 1. This is the polynomial which I am considering. So this is known as interpolating polynomial, or sometimes people call it as also a interpolating function, right? So this, what is this? This Px is known as interpolating function, or sorry, polynomial. Now we will use this polynomial for the Lagrange's interpolation polynomial method. So means this polynomial is used in Lagrange's interpolation method. Means this polynomial is used in Lagrange's interpolation polynomial method. Right. So for the sake of simplicity, what I will do, I will consider a second order polynomial and I want to fit that second order polynomial. Second order means I am having only 3 data points, x0, x1 and x2. Right. So let us switch over from here nth order polynomial to the second order polynomial just for the sake of simplicity. So consider a second order polynomial So if we consider a second order polynomial and how that can be represented, let us call that as P2x. So how it can be written as a0 x minus x1 x minus x2 plus a1 x minus x0 x minus x2 plus a2 x minus x0 and x minus x1. This is the second order polynomial. And so that means 3 data points are given to me. How many data points are there? 3 data points are given to me. So if 3 data points are given to me, what does that mean? That x is equal to 1 is x and here it is f of x. So what has been given to me? Means 3 data points are given for the quadratic polynomial, right? So what is it? It is x0, x1, x2. Here let me call it as corresponding to it is f0, it is f1 and say it is f of 2. This is given to me. Means the points which are given to me x0, f0, x1, f1 and x2 and f2. These are the data points I am having, right? So what is my objective? My objective is to find out the value of a0, a1 and a2. So let me try to find out the value of the polynomial corresponding to first point. So P2x0 will be what? When I put this value P2x0, so that means in place of x, when I am putting x0, then only this term will be non-zero and rest of the terms will become 0. Because when I put x0 in this equation, in this polynomial, given polynomial, then this term will also become 0, this term will also become 0, only we are having this is non-zero and it is a0, x0 minus x1 and x0 minus x2. And similarly, P2x1, for this x1, this will be 0, this will be 0, but this will be non-zero. So it is a1, x1 minus x0 and x1 minus x2. And what is P2? And it is P3, sorry, not P3, but it is P2 x2. It is what? This will be 0, this will be 0 and this will be non-zero. Is it clear? Okay. So that means it is a2, x2 minus x0 and x2 minus x1. And what is it? It's equivalent to f0, it is equivalent to f1 and it is equivalent to f of 2. So if it is so, that means from here I can estimate the value of what? Using this I can estimate value of a0. What is a0? a0 is equal to f naught, x naught minus x1 and x naught minus x2. From here a1 can be estimated as f naught upon x1 minus x naught and x1 minus x2, and a2 can be estimated it is f1 and it is f of 2 over x2 minus x naught and it is x2 minus x1. That's what we are getting. Now putting these three values of a0, a1 and a2 in this polynomial, and that is the required polynomial. That is the required polynomial. So therefore p2x can be written as this p2 x is what? It is f of naught over x naught minus x1, it is x naught minus x2, here it is x minus x1 and x minus x2, plus f1 upon x1 minus x naught, and here it is x1 minus x2, and here it is x minus x naught, and here it is x minus x2, plus f of 2 upon x2 minus x1, x naught, x2 minus x1 into x minus x naught and x minus x2. Clear? So therefore this p2x is simply it is f of naught, it is x minus x1, x minus x2 over x naught minus x1, x naught minus x2, plus f of 1, what is it? X minus x naught, x minus x2 over x1 minus x naught, and here it is x1 minus x2, plus f of 2, it is x minus x naught, x minus x1 whole upon what? It is x 2 minus x naught and x2 minus x1. Yeah, very simple. And let me simplify it. Let us call it as L naught x. It is f1 and let us call it as L1x, and it is f of 2 because I want to generalize it, L2x. So if I put these values here, then it can be written as summation f of I Lix, where Li varies from 0 to 2. I varies from 0 to 2. So therefore here Lix is what? This Lix, let me try to write in that how. It is x minus xj and xi minus xj. It is product, j varies from 0 to 2, and here j is not equal to I, because this can never be equal to this one. See it, right? And to generalize it, how this can be written as this Pnx is equal to, it is summation I varies from 0 to n fi Lix, and here Lix is equal to product I varies from 0 to n and I is not equal to j. It is x minus xj over xi minus xj, right? So this is the Lagrange's polynomial. It is Lagrange's polynomial. So this is a very beautiful method and interesting, and it's very simple. And using this you can estimate the same problem. So let us try to solve the same problem which we have discussed in the linear interpolation. I will discuss again same problem and try to solve that using this. So let us have a look at that method. So let us try to solve the same problem again. X is given to me, and for x I will choose only 3 points because I will use a quadratic polynomial, right? So x is 2, 3, 4, and corresponding to it, it is 1.4142, 1.7321, and here it is 2. It is f of x. Let us try to solve the same problem. So we are interested to find out P22 at 2.5, and what is it? F of naught, x minus x1, यही आएगा, ठीक है, x minus x2 upon x naught minus x1, and here it is x naught minus x2 plus f of 1 x minus x naught x minus x2 over x naught minus x naught minus x1 minus x1 minus x naught, and it is x1 minus x2 plus f of 2 x minus x naught and x minus x1. Here it is x2 minus x naught and x2 minus x1. So what is it? This is x naught, this is x1, this is x2, and x is what? X is 2.5, which I have written here. Sorry, let me write down it. So P to 2.5 is what? Let me put their values. It is f of naught, it is f of 1, it is f of 2. So let us put these values. So it is 1.4142, 2.5 minus 2.0, 2.5 minus, sorry, it is x1 is 3, right? 3.0, and 2.5 minus 4 divided by what? These values. So in the denominator it will be x naught, so it is 2 minus 3 and 2 minus 4 plus next value will be 1.7321 into 2.5 minus 2, 2.5 minus 4 divided by what? It is 3.0 minus 2, 3.0 minus 4 plus 2.0, 2.5 minus 2.0, 2.5 minus 3.0 whole divided by 4.0 minus 2.0, and here it is 4.0 minus 3.0. And when I will solve this, the result which I am getting, it is 1.5794. So let me compare this result with earlier results. So earlier I did linear interpolation using small interval and large interval, and here is Lagrange's method, and it is the actual answer. So so here the small interval 2 to 3, at that our result is 1.7532, and when we have taken the large interval 1.5607, and Lagrange's method is 1.5794, and actual answer is 1.5811. So now see how things has been improved. This is much more closer than to that. So if that means in this way I can improve the results, right? So this is all about this Lagrange's interpolation method. So that's all for today's lecture.